Hello everyone, welcome back to my channel. I am Vamshik Shetty, pursuing second year B Engineering, Teswara College of Engineering, Bangalore. Today in this video, we are going to discuss about the major topic in the automata theory, that is conversion from non-deterministic finite automata, that is NFA, to deterministic finite automata, DFA. So let us discuss about the each and every topic in conversion from NFA to DFA. First, we are going to discuss about the what is DFA. DFA, which is also called as deterministic finite automata. The deterministic finite automata consists of finite set of states, often denoted by Q, and finite set of input symbols, often denoted by summation, and a transition function that takes as arguments a state and an input symbol and returns a state. The transition function will be commonly denoted by delta. If Q is a state and A is an input symbol, then delta of Q comma A is the state P such that there is an arc labeled from Q to P square and a start state, one of the states in Q, and a set of final states or accepting the states F. The state F is a subset of Q. The DFA, which is commonly represented by the phi tuple notation, that is A is equals to Q comma summation comma delta comma Q naught comma F, where Q is the set of states and summation is the set of input symbol, and delta is the transition function, and Q naught is the starting state of the Q, and F is the final state of the Q. So this is the DFA. Now let us discuss about the NFA, that is non-deterministic finite automata. Now let us introduce the formal notion associated with the non-deterministic finite automata. The difference between DFAs and NFAs will be pointed out as we do. An NFA is represented essentially like DFA, that is both NFA and DFA is represented in the same way, that is A equals to Q comma summation comma delta comma Q naught comma F, where Q is the set of states, summation is the set of input symbols, and Q naught is the initial state or starting state of the Q, and F is the final state of the Q. And the only difference between the NFA and DFA is the transition function. The transition function is a function that takes a state in Q and an input symbol in summation as arguments and returns a subset of Q. Notice that the only difference between the NFA and DFA is the type of value that delta returns, a set of states in case of NFA and a single state in case of DFA. We know that in DFA, a state which accepts an input symbol, it will move on to the single state, where in case of NFA, the state which on accepting the input symbol, it is going to move to the two or more states. That is the only difference between the NFA and DFA. So we got to know about the what is DFA and what is NFA. Now let us move on to the conversion from NFA to DFA, that is non-deterministic to deterministic. For this, we are gonna consider a simple examples. That is, this is the given NFA example where it has three states Q0, Q1, Q2, and the two input symbol A and B. Before going to convert this NFA to DFA, we're gonna consider the transition table. The transition tables consist of the transition function delta and the two input symbol. We know that the input symbols from this diagram, that is A and B, and there are three states in the diagram, that is Q0, Q1 and Q2, where Q0 is the starting state and Q2 is the final state. We know that the final state is enclosed within the two circles, though, so we're gonna take the Q2 as the final state. Now we're gonna fill the transition table from the given diagram, where Q0 and accepting A in the transition in the figure, we see that the Q0 and accepting A, it is moving to the Q0 itself. So we're gonna take Q0, and Q0 on accepting B, it is moving on to the Q0 and Q1 both. So we're gonna take Q0 and Q1. Q1 on accepting B, it is moving on Q1 on accepting A, it is moving on to the null state. So it is not moving on to the any of the state. So we're gonna take it as null state. Q1 on accepting B, it is moving to the Q2 state. Now let us take the last state Q2, where Q2 on accepting A, it is not moving to the any of the states, so we're gonna take it as null, and Q2 on accepting B, it is not moving to the any of the state, so we're gonna take it as null. So this is the basic transition table which we're gonna construct from the given diagram. Now let us discuss about the each and every states. So we're gonna consider the each and every state. Before considering the each and every state, we're gonna consider the transition table which we have taken from the previous diagram. So this is the transition table which we have constructed from the previous diagram. So now let us discuss about the each and every state. from the given following steps. In the first step, we are gonna consider the Q naught state, that is the first state, Q naught state. In the Q naught state on accepting A, Q naught state on accepting A, we can see that from the transition table, Q naught on accepting A, it is moving on to the Q naught itself. And Q naught on accepting B, Q naught on accepting B from the transition table, we can see that Q naught on accepting B, it is moving on to the Q naught comma Q1 state. So we can see that Q naught is already present in the transition table, so we don't need to consider it as a new state. Whereas Q naught comma Q1 is not present in the transition table, so we're gonna consider it as a new state. So we're gonna take it as a new state in transition table also. And this completes the first state, that is Q naught state. Now let us discuss about the Q1 state. In step 2, we're gonna consider the Q1 state. In Q1 state, Q1 on accepting A, Q1 on accepting A, it is moving on to the null state. And Q1 on accepting B, from the transition table we can see that Q1 on accepting B, it is moving on to the Q2 state. Since Q2 is already present in the transition table, we don't need to consider the Q2 state as the new state. So this completes the second state, that is Q1 state. Now let us move on to the third state from the transition table. The third state is the Q2 state. In step 3, we're gonna consider the third state, Q2 state. Here Q2 on accepting A. Q2 on accepting A, from transition table we can see that Q2 on accepting A, it is moving on to the null state, and Q2 on accepting B, it is moving on to the same null state. So since there is no change in the no difference in the null state, so it not going to make any difference, so we don't need to consider it as the new state. So this completes the third state. Next, we are going to consider the new state Q naught comma Q1 in the transition table, which we have got from the step 1, that is on considering the Q naught state, we got the new state Q naught comma Q1. So now let us discuss about the Q naught comma Q1 in the step 4. In step 4, consider the state Q naught comma Q1. Now Q naught comma Q1 on accepting A, Q naught comma Q1 on accepting A, we don't have the direct function, so we're gonna split this function as the Q naught on accepting A union Q1 on accepting A. We have the functions that Q naught on accepting A and Q1 on accepting A, so we're gonna split this function. So now Q naught Q1 on accepting A will be Q naught on accepting A will be Q naught, and Q1 on accepting A will be null. So we're gonna combine Q naught and null. On combining Q naught and Q1, we're gonna get Q naught comma Q1 on accepting A will be Q naught itself. Since Q naught is already present in the transition table, we don't need to consider it as the new state. So now let us move on to the Q naught comma Q1 on accepting B. Since Q naught comma Q1 on accepting B is also not in the we don't have the direct function, so we're gonna split this function as Q naught on accepting B and Q1 on accepting B. So we have these values in the transition table, so we take the values from the transition table. Now Q naught comma Q1 on accepting B will be Q naught on accepting B is the Q naught comma Q1, and Q1 on accepting B will be Q2. So we're gonna combine Q naught comma Q1 and the Q2. So on combining this Q naught comma Q1 and Q2, we're gonna get Q naught comma Q1 on accepting B will be Q naught, Q1 and Q2. On combining the three states, we're gonna get Q naught comma Q1 comma Q2. Since this state is not present in the transition table, we're gonna consider this as the new state. And we're gonna consider it in transition table also. Before considering the transition table, we're gonna fill these values of the Q naught comma Q1 from the step 4. Q naught comma Q1 on accepting A will be Q naught, and Q naught comma Q1 on accepting B is the Q naught, Q1 and Q2 from the step 4. And we have the new state, that is Q naught comma Q1 comma Q2. We're gonna take it as the new state also into the transition table. So now this completes the step 4. Now in the step 5, we gonna take the new state, that is Q naught comma Q1 comma Q2. Now let us move on to the step 5. Yeah, before considering the step 5, we're gonna consider the transition table which we have created from the previous slide. So this is the final transition table which we have created from the previous previous steps and the diagram. Now we are gonna take the Q naught comma Q1 comma Q2 as the new state in the step 5. Yeah, consider the new state, and considering the new state as the Q naught comma Q1 comma Q2. Q naught comma Q1 comma Q2 on accepting A is the first state, where Q naught comma Q1 comma Q2 on accepting A, we don't have any direct functions, so we're gonna split this function as the Q naught comma A union q1 comma a union q2 comma a. We have the direct functions from the transition table, so we're gonna consider these functions. q0 comma q1 comma q2 comma a on accepting a will be q0 union null. So this is the values which we have taken from the transition table. On combining these values, we're gonna get q0 comma q1 comma q2 on accepting a will be q0 itself. q0 is already present in the transition table, so we don't need to consider this as the new state. So now let us move on to the next q0 comma q1 comma q2 on accepting b. q0 comma q1 comma q2 on accepting b will be so we don't have the any direct functions from the transition table. So we're gonna split this function as same in the above. q0 comma q0 on accepting b union q1 on accepting b union q2 on accepting b. So we have the values from the transition table. So we're gonna take these values from the transition table. q0 comma q1 comma q2 on accepting b will be q0 comma q1 q2 and null. So we're gonna take these values from the transition table and we are gonna combine this in the equation. So q0 comma q1 union q2 union null. So we're gonna combine these values and we are gonna get q0 comma q1 comma q2 on accepting b will be q0 comma q1 comma q2. Since we know that q0 comma q1 comma q2 is already present in the transition table, so we don't need to consider this in the transition table. This completes the step 5. So we can see that all the states have been evaluated. So we're gonna end this transition table and we're gonna take these values from the transition table of the q0 comma q1 comma q2 from the step 5. So q0 comma q1 comma q2 on accepting a will move on to the q0 state, and q0 comma q1 comma q2 on accepting b will move on to the q0 comma q1 comma q2 on itself. So this completes the all the states, and this frames the final transition table. From this final transition table we're gonna construct the DFA. So first we have constructed the from the NFA we have taken the transition table, and from the transition table we have constructed the final transition by taking all the steps, all the states in the steps in the step format. So this frame the final transition table, and this from this final transition table we're gonna consider the DFA. Now we're gonna consider the DFA. Before considering the DFA, so we're gonna take the final transition table from the given from the previous steps. So this is the final transition table which we have constructed from the previous steps. From the transition table we can see that there are 5 states: q0 q1 q2 q0 comma q1 and q0 comma q1 comma q2. So we're gonna encircle within the we can enclose within the circle as the five states, that is q0 q1 q2 q0 comma q1 q0 comma q1 comma q2. So we can see that q0 is the starting state, so we're gonna take the q0 as the starting state, and q2 is the final state, so we're gonna enclose within the two circles. We know that q2 is also associated with the q0 comma q1 comma q2, so we're gonna take q0 comma q1 comma q2 is also as the final state. So we're gonna enclose the q0 comma q1 comma q2 within the two circles. So this completes the states. Now let us move on to the input symbols from the transition table, where we can see that q0 on accepting a, q0 on accepting a is moving on to the q0 itself. So we're gonna take q0 on accepting a, it is moving on to the q0 itself. And from the transition table we can see that q0 on accepting b, it is moving on to the q0 comma q1. q0 on accepting b, it is moving on to the q0 comma q1. This completes the first state. Now let us move on to the next state, that is q1 state. q1 on accepting a, it is moving on to the null state, so we don't need to consider the null state. And q1 on accepting b, it is moving to the q2 state. From the transition table we can see that q1 on accepting b, it is moving to the q2 state. This completes the q1 state. Now let us move on to the q2 state. q2 state on accepting a, it is moving on to the null state, and q2 on accepting b, it is moving on to the null state itself. So we don't need to consider the null state as we said before. This completes the q2 state. Now let us move on to the third state, q0 comma q1. q0 comma q1 on accepting a, it is moving on to the q0 state. From the transition table you can see that q0 comma q1 on accepting a, it is moving on to the q0 state. Now let us now we can see that q0 comma q1 on accepting b, it is moving on to the q0 comma q1 comma q2. Yeah, we have labeled q0 comma q1 on accepting b, it is moving to the q0 comma q1 comma q2. So this completes the fourth state, that is q0 comma q1. Now let us move on to the last state, that is q0 comma q1 comma q2. q0 comma q1 comma q2 on moving on to the on accepting a, it is moving on to the q0 state. So we gonna label q0 comma q1 on accepting comma q2 on accepting a, it is moving on to the q0 state. And now q0 comma q1 comma q2 on accepting b, it is moving on to the q0 comma q1 comma q2 itself. So we're gonna take the self loop as q0 comma q1 comma q2 on accepting b, it is moving on to the q0 comma q1 comma q2 itself. So this completes the all the states. So we can see that from the figure we can see that all the states on accepting a and b, it is moving on to the single state itself. So this completes the this we have constructed the DFA from the final transition table. So this completes the now we have constructed the DFA from the given NFA using the final transition using the transition table and the steps involved in it. So this is the final DFA, that is deterministic finite automata from the given NFA. Yeah, that's it for this video. Thank you. For more videos, please like, share and subscribe the channel. Thank you.